Physics, Part 92. Newton's first law of motion. Everybody continues in its state of rest or of uniform motion in a straight line unless acted upon by a force. Newton's second law of motion. Force is proportional to mass into acceleration, or F is equal to ma, where force F in newtons, mass m in kilogram, and acceleration a is in meters per second per second. Third law of motion. Whenever one body exerts a force on another, the second exerts an equal and opposite force on the first. Weight W and mass m are related by W is equal to mg, where g is the acceleration of free fall. There are section questions. Number 1, a net force of 95 Newton accelerates an object of 1.9 ms. Calculate the mass of the object. Number 2, a parachute trainee jumps from a platform 3.0 meter high. When he reaches the ground, he bends his knees to cushion the fall. His torso accelerates over a distance of 0.65 meter. Calculate A, the speed of the trainee just before he reaches the ground. B, the deceleration of his torso. C, the average force exerted on his torso of mass 45 kg by his legs during the deceleration. Number 3, if the acceleration of a body is 0, does this mean that no force acts on it? Number 4, a railway engine pulls two carriages of equal mass with uniform acceleration. The tension in coupling between the engine and the first carriage is T. Deduce the tension in coupling between the first and second carriages. Number 5, what is your mass? What is your weight? 5.5, momentum. At the end of section, we should be able to define linear momentum as the product of mass and velocity. Should be able to define force as the rate of change of momentum. Should be able to state the principle of conservation of momentum. Should be able to apply the principle of conservation of momentum to solve simple problems, including elastic and inelastic interactions between two bodies in one dimension. Should be able to recognize that for a perfect elastic collision, the relative speed of approach is equal to the relative speed of separation. Should be able to show an understanding that whilst momentum of a system is always conserved, in interactions between bodies, some change in kinetic energy usually takes place. We shall now introduce quantity called momentum and see how Newton's laws may be related to it. The momentum of a particle is defined as the product of its mass and its velocity. In volts, momentum is equal to mass into velocity, and in symbols, P is equal to mv. And this is, as it goes along, we'll talk about linear momentum. We'll talk about the momentum being constant, and we'll talk about the specific case. We'll also have an example of the conservation of momentum, and we'll move along with it. We'll have system of two particles. F is equal to ma.
कहती कि तूने मुझे इतना जवाब क्यों दिया? क्या फीडबैक मैं तो देख के जा तो जा